Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we will be diving into AWS Storage Gateway, what it is, how it works, and how it helps you connect your on-premises environments to AWS storage services. We'll cover the different gateway types and typical use cases to start using AWS Storage Gateway. Let's get started. Hybrid cloud environments have become the norm for many organizations, driven by factors like security and compliance requirements, long-term cloud migration strategies, and the need to support legacy systems. In these scenarios, it's critical to have a solution that connects on-premises infrastructure with cloud storage in a seamless and secure way. AWS Storage Gateway is purpose-built for this need. It's a hybrid cloud storage service that allows your on-premises applications to integrate directly with AWS storage services without rewriting code or overhauling existing systems. With Storage Gateway, you can extend your business applications to the cloud with minimal disruption. Whether you're looking to optimize backups, scale storage, or modernize your infrastructure over time, Storage Gateway supports a wide spectrum of hybrid use cases. It acts as the glue between your data center and AWS, allowing you to take advantage of cloud scalability, durability, and economics, while still maintaining the performance and workflows your users expect locally. The AWS Storage Gateway family includes 3 gateway types, each tailored for different storage needs in hybrid cloud environments, allowing you to extend your on-prem infrastructure to AWS seamlessly. First, we have the File Gateway, which allows file-based applications to store and retrieve data as objects in Amazon S3 using standard NFS or SMB protocols. It includes local caching to provide low-latency access to frequently used files and is great for use cases like file shares, content repositories, and ML pipelines. Next is the Volume Gateway, which provides block storage to your on-premises systems backed by cloud-based storage. It supports EBS snapshots and cloning, along with local caching, making it ideal for backup, disaster recovery, and database storage scenarios. And finally, the Tape Gateway is designed as a drop-in replacement for physical tape libraries. It integrates with existing backup software and stores virtual tapes in AWS, while offering local caching for fast restores, perfect for modernizing backup and archive workflows without disrupting existing processes. Each gateway addresses specific hybrid storage challenges, and in the following slides, we'll explore how they work and where they fit into your architecture. Let's take a look at some of the key features that are common across the AWS Storage Gateway family. Designed to provide seamless integration, performance, and scalability for hybrid cloud storage workflows. Standard storage protocols. AWS storage services support industry-standard storage protocols, ensuring seamless integration with existing applications and infrastructure. Whether using NFS, Network File System, SMB, Server Message Block, IC, Internet Small Computer Systems Interface, or Object Storage APIs, AWS storage solutions allow organizations to connect their workloads to the cloud without requiring major application changes. This compatibility enables businesses to leverage cloud storage for diverse use cases, such as file sharing, backup and recovery, database storage, and archival solutions, while maintaining a familiar storage environment. Fully managed cache. AWS storage solutions, such as AWS Storage Gateway, provide a fully managed local cache to enhance performance by reducing latency and minimizing data transfer costs. Frequently accessed data is stored locally on premises, allowing applications to retrieve it quickly without always accessing cloud storage. This feature is particularly useful for workloads that require low latency access to active data, while benefiting from the scalability and durability of AWS storage in the background. By automatically synchronizing data between on-premises storage and the cloud, AWS ensures that users experience fast, uninterrupted access to their critical data while optimizing costs and efficiency. Optimized data transfer. AWS storage services incorporate intelligent data transfer optimizations to reduce network bandwidth consumption and accelerate data migration to the cloud. Features such as multi-part uploads, data deduplication, compression, and WAN acceleration ensure that data is moved efficiently while minimizing latency and costs. Services like AWS DataSync and AWS Snow Family provide additional options for large-scale data transfer, supporting organizations that need to migrate petabytes of data quickly. With these optimizations, businesses can seamlessly integrate cloud storage into their workflows without disrupting performance. Durable storage. AWS storage solutions are designed with high durability and availability to ensure long-term data protection. Storage services like Amazon S3, Amazon EBS, Amazon EFS, and Amazon FSx offer built-in redundancy, automatically replicating data across multiple availability zones, AZs, and AWS regions. Amazon S3, for example, provides 99.999999% 11 nines durability, ensuring that data remains intact even in the event of hardware failures. Additionally, AWS offers various data protection features, including versioning, backup and recovery, cross-region replication, and lifecycle policies, helping businesses safeguard their critical data from accidental deletions, ransomware attacks, or disasters. This illustration represents how AWS Storage Gateway acts as a bridge between your on-premises infrastructure and AWS cloud storage services. On the left side, we see typical components of an on-premises environment, such as application servers, file servers, and end-user workstations. These systems interact with a local cache or appliance, whether virtual or physical, using standard protocols like NFS, SMB, or ICC, depending on the gateway type in use. This local gateway component plays a critical role. It provides low latency access to frequently used data through local caching, ensuring performance-sensitive applications can function as if all the data were stored locally, even though the full dataset resides in the cloud. On the right side, we see the AWS Cloud, where the Storage Gateway service integrates natively with AWS storage solutions, such as Amazon S3 for file and backup data, Amazon EBS for block volumes and snapshots, and Amazon S3 Glacier for long-term tape archive replacement. All of this is managed securely and efficiently by AWS. AWS offers a suite of monitoring and management tools such as Amazon CloudWatch for performance metrics and logging, AWS Backup for centralized backup orchestration, and AWS IAM for access control and security policies. These services provide visibility, automation, and governance over your hybrid storage workflows. Together, this architecture allows organizations to modernize their storage strategy by seamlessly extending existing applications to the cloud without re-architecting systems or disrupting business operations. AWS File Gateway is a hybrid cloud storage solution that enables organizations to seamlessly integrate on-premises applications with Amazon S3. It provides file-based access to cloud storage using industry-standard protocols such as NFS, Network File System, and SMB, Server Message Block, making it easy for businesses to extend their existing storage infrastructure to the cloud without modifying their applications. By storing files as objects in Amazon S3 buckets, File Gateway ensures scalability, durability, and cost efficiency, while allowing users to interact with their data in a familiar file system format. One of the key features of AWS File Gateway is its intelligent local caching, which helps reduce cloud data retrieval costs and improves performance by keeping frequently accessed files available on premises. This is particularly beneficial for workloads requiring low latency access to data, while still leveraging Amazon S3 as the primary storage backend. File Gateway also supports data lifecycle policies, automatically archiving files to Amazon S3 Glacier for long-term retention, which helps businesses optimize storage costs while maintaining accessibility. AWS File Gateway is widely used for hybrid cloud file storage, backup and disaster recovery, big data analytics, and media content distribution. Organizations can store backups in Amazon S3, benefiting from versioning, cross-region replication, and encryption for data protection. Businesses dealing with large-scale data processing, such as big data analytics and machine learning workloads, can store files in S3 and process them with AWS services without disrupting local operations. Additionally, File Gateway is an ideal solution for media and entertainment companies, allowing them to efficiently store and distribute large media files in the cloud, while maintaining on-premises access for content editing and streaming. With seamless integration, cost efficiency, and high durability, AWS File Gateway is an essential tool for businesses looking to bridge their on-premises file storage with scalable cloud storage. It enables organizations to benefit from Amazon S3's high availability and cost-effective storage tiers, while ensuring local file access for applications that require fast and reliable data retrieval. Amazon FSx File Gateway is a hybrid cloud storage solution that on-premises applications and users to access fully managed Amazon FSx file systems for Windows, Lustre, and NetApp. It enables you to expose industry-standard file protocols such as SMB for Windows-based environments and NFS for Linux or Unix-based systems. This ensures seamless compatibility with your current file-based workloads and applications. A core strength of FSx File Gateway is its use of local caching. Frequently accessed data is cached locally, delivering low latency access for users and significantly reducing the need to constantly pull data over the network from the cloud. This not only improves performance but also helps control bandwidth usage. From the user's perspective, nothing changes. They continue to access file shares using the same familiar paths and workflows. Behind the scenes, however, the actual storage resides in the cloud within Amazon FSx. This allows you to extend the value of FSx to your on-prem environment without disrupting users. It's particularly useful for lift and shift scenarios. You can migrate data to FSx in the cloud while continuing to serve it locally during and after the transition. It's ideal for workloads like virtual desktop infrastructure, VDI, backup and archival, or any scenario where low latency access to shared data is required from on-premises locations. One of the biggest advantages is the reduction in on-premises storage complexity. Rather than managing local NAS hardware, you get the benefit of a fully managed FSx file system in the cloud, with on-premises access provided through the gateway. Deployment is simple and flexible. Management and monitoring are centralized through the AWS Storage Gateway console, making administration straightforward and consistent. Amazon FSx for Windows File Server is a fully managed native Windows file system that provides shared file storage built on Windows Server. It's ideal for organizations looking to lift and shift their Windows-based applications to the cloud without having to refactor or compromise on features. It supports the full Windows NTFS file system, including file permissions, encryption, and compression. Just like on-premises Windows file servers, FSx supports the SMB protocol and integrates natively with Microsoft Active Directory, whether it's AWS Managed AD or your self-managed AD, so authentication and authorization remain seamless. This gives you full support for NTFS access control lists, ACLs, user quotas, and enterprise-grade security controls. When it comes to performance, FSx for Windows is built to scale. It can handle tens of gigabytes per second of throughput, millions of IOPS, and hundreds of petabytes of storage, making it ideal for workloads like enterprise databases, content repositories, and high-performance analytics. You also have flexibility in storage options. SSD-backed storage is perfect for latency-sensitive applications like SQL Server, media processing, or analytics workloads. On the other hand, HDD-backed storage offers a more cost-effective option for broader use cases, such as user home directories or content management systems. For enterprises looking to group multiple file systems under one logical view, FSx supports Microsoft DFS namespaces. This allows you to aggregate multiple shares into a single unified namespace for easier access and organization. FSx is also well-suited for hybrid cloud use cases. You can access the file system from your on-premises infrastructure using AWS Direct Connect or VPN. And if you need high availability, FSx supports multi-AZ deployments with automatic failover to ensure business continuity. Interestingly, although FSx is Windows native, you can mount it on Linux-based EC2 instances using the SMB protocol, which is useful in mixed OS environments. Finally, for data protection and compliance, FSx automatically performs daily backups to Amazon S3, and you can customize the backup schedule to meet your organization's RPO and retention requirements. Amazon FSx for Lustre is a high-performance file system purpose-built for compute-intensive workloads like machine learning training, high-performance computing, financial simulations, electronic design automation, and large-scale video rendering. The name Lustre itself is a blend of Linux and cluster, which reflects its origins and tight integration with large-scale Linux-based compute environments. This file system excels in scenarios where you need extremely fast access to massive data sets. FSX for Lustre scales impressively, offering hundreds of gigabytes per second in throughput, millions of IOPS, and sub-millisecond latencies. This level of performance makes it ideal for applications that would otherwise be bottlenecked by traditional file storage solutions. There are two storage options depending on your workload profile. SSD-backed storage for low-latency, random I/O-heavy tasks, such as training AI models with many small files, and HDD-backed storage optimized for large, sequential throughput-heavy operations like genome sequencing or media transcoding. FSX for Lustre is also fully POSIX compliant, so any Linux-based application that expects a standard file system interface will work without modification. This makes it a perfect fit for tools and frameworks commonly used in HPC and ML workflows. Hybrid environments are also supported. You can access FSX for Lustre from on-premises compute clusters via VPN or Direct Connect, which is ideal for hybrid cloud HPC or burst-to-cloud scenarios. You can deploy FSX for Lustre in two distinct modes, depending on your workload needs. For short-lived, high-speed processing tasks, such as large-scale simulations or temporary data crunching, you can use ephemeral scratch file systems, which are optimized for performance, but don't include built-in backups. On the other hand, for longer-term storage or workloads that need to be run repeatedly, you can choose persistent file systems, which include built-in backup capabilities and are ideal for maintaining data durability over time. One of the biggest advantages of FSX for Lustre is its seamless integration with Amazon S3. You can import data directly from S3 and have it immediately accessible as files on the Lustre file system. After processing, you can also export the results back to S3, which simplifies your data workflows and reduces the need for manual staging or transfer steps. Amazon FSX for NetApp ONTAP brings the full capabilities of NetApp's enterprise-grade ONTAP file system to the AWS cloud in a fully managed form. It's purpose-built for organizations looking to move their existing ONTAP or traditional NAS workloads to the cloud with minimal operational disruption. One of the key advantages of FSX for ONTAP is its multi-protocol support. It allows access via NFS, SMB, and iSCSI, making it highly versatile for both file and block storage use cases. This makes it a great fit for mixed environment workloads that span Linux, Windows, and macOS systems. In terms of platform compatibility, it's incredibly flexible. FSX for ONTAP works natively with Amazon EC2, ECS, and EKS, as well as with VMware Cloud on AWS, and user-facing services like Amazon Workspaces and AppStream. This wide range of support makes it easy to centralize storage and ensure consistency across compute environments. The storage system is also elastic, automatically scaling capacity up or down based on usage. This eliminates the need for manual provisioning and ensures you're only paying for what you actually use. From a data management standpoint, FSX for ONTAP brings all the powerful features you'd expect from NetApp: built-in snapshots, replication, compression, and data deduplication. These features help reduce storage costs, increase efficiency, and support robust backup and disaster recovery strategies. Another powerful capability is instantaneous, point-in-time cloning. This allows you to create space-efficient clones of volumes almost instantly, which is incredibly useful for test dev environments, analytics workloads, or staging deployments. It's also highly migration-friendly. Organizations that have built their storage infrastructure on ONTAP or traditional NAS can lift and shift workloads directly into AWS with very little re-architecture. You maintain the same tooling and data management workflows, just in a cloud-native setting. Finally, FSX for ONTAP is built with enterprise-grade performance and availability in mind. You can deploy it in high availability mode across multiple availability zones and take advantage of NetApp's SnapMirror technology for replicating data across regions or back to on-premises environments. Amazon FSX for OpenZFS is a fully managed file system that brings the powerful enterprise-grade capabilities of the OpenZFS platform to AWS. It's designed for teams that already use ZFS on-premises and want to migrate to the cloud without giving up the native features and performance they rely on. FSX for OpenZFS provides robust support for Linux and Unix-based applications that require reliable file locking, access control, and POSIX compliance. This makes it a great fit for legacy and modern applications alike. Performance is a major strength. FSX for OpenZFS can deliver up to 1 million IOPS with sub-half millisecond latencies. This makes it ideal for workloads that are both high throughput and latency sensitive, such as continuous integration pipelines, software builds, analytics workloads, and dev test environments. From a data management standpoint, FSX for OpenZFS supports snapshots and compression out of the box. Snapshots are point in time and space efficient, and data compression helps reduce storage costs while maintaining high performance. One of its standout features is instantaneous cloning. You can create zero-copy clones of file systems in seconds. This is extremely useful for testing new workloads, replicating environments for QA, or provisioning identical dev environments quickly and consistently. For customers already using OpenZFS or ZFS-based systems, FSX for OpenZFS offers a migration-friendly path to the cloud. You retain the same ZFS native tools and administrative capabilities, but without the overhead of managing storage infrastructure. And finally, like other FSX services, OpenZFS is well integrated into the AWS ecosystem. Whether you're running workloads on bare EC2 instances, inside Kubernetes pods, or on VMware-based stacks, FSX for OpenZFS fits right in, allowing you to extend your storage to match your compute needs seamlessly. AWS Volume Gateway is a hybrid cloud storage solution designed to extend on-premises block storage into the AWS cloud seamlessly. It presents ISC-based storage volumes to your on-premises applications while backing those volumes with the scalability, durability, and cost efficiency of Amazon S3 and EBS. This makes it an excellent fit for workloads that require low latency local access, but still want to benefit from cloud-based storage capabilities. Volume Gateway operates in two flexible modes. In cached volumes mode, only the frequently accessed data is stored locally, while the complete dataset resides in Amazon S3. This significantly reduces the need for on-prem storage capacity while still delivering high performance. On the other hand, stored volumes retain the entire dataset on-premises, but asynchronously back up the data to AWS, ideal for organizations that want to keep their primary storage local while enabling cloud-based disaster recovery. One of the standout features of Volume Gateway is its ability to create point-in-time snapshots of your volumes. These snapshots are stored in Amazon EBS and can be easily restored to your local environment or to AWS EC2 instances, supporting both backup strategies and smooth cloud migrations. This flexibility is key to enabling resilient and agile infrastructure planning. Security is built in across the board. Data is encrypted both at rest and in transit, and the service integrates with AWS IAM for fine-grained access control. It also supports automated replication across AWS availability zones, ensuring high availability and data protection. By blending on-prem performance with cloud resilience and scalability, Volume Gateway offers an ideal bridge for businesses transitioning toward cloud-native architectures while maintaining continuity with their existing systems. AWS Tape Gateway is a purpose-built solution that enables businesses to modernize their backup and archival infrastructure by replacing physical tape systems with a cloud-backed virtual tape library, VTL. What makes Tape Gateway particularly compelling is that it integrates directly with your existing backup software using industry-standard ICC, allowing you to retain your current backup workflows with minimal disruption. Behind the scenes, backup data is stored in Amazon S3 for active workloads and can be automatically moved to Amazon S3 Glacier or S3 Glacier Deep Archive for long-term retention at a significantly lower cost. This automated lifecycle management makes it easy to implement tiered storage strategies, keeping recent backups readily accessible while moving older data to lower-cost archival storage, all without manual intervention. From a security and compliance perspective, Tape Gateway offers strong protections. Data is encrypted both in transit and at rest, and it integrates with AWS Identity and Access Management, IAM, for fine-grained access control. For customers in regulated industries, it also supports WORM, write once, read many, storage policies, which are essential for ensuring data immutability and regulatory compliance. Tape Gateway is especially valuable for organizations that have large volumes of long-term backups and need to retain them for years, such as in healthcare, finance, or media. It delivers the scalability, durability, and geographic redundancy of the AWS cloud without the operational overhead of managing physical tapes or tape libraries. Tape Gateway offers a cloud-native, highly cost-effective solution for backup modernization, archiving, and disaster recovery, allowing you to simplify operations while meeting long-term data retention requirements. Finally, the AWS Storage Gateway hardware appliance. This hardware appliance is a fully integrated, pre-configured physical device that makes it easy for organizations to deploy Storage Gateway in their on-premises environments without needing to provision or manage separate hardware or virtualization infrastructure. This is especially useful for businesses that either lack the resources for virtual machine deployments or prefer a dedicated, turnkey solution. The appliance offers a plug-and-play experience, enabling you to quickly connect your on-prem applications to AWS Cloud Storage using any of the three gateway types: File Gateway, Volume Gateway, or Tape Gateway. One of the standout benefits of the hardware appliance is its predictable performance. It comes equipped with optimized compute, memory, and network capabilities, meaning there's no guesswork or overhead in sizing or configuring infrastructure. This translates to faster deployments, more consistent throughput, and less administrative effort. In addition, it supports all the core features of Storage Gateway, such as local caching for low-latency access to frequently used data, automated synchronization with AWS services like Amazon S3, and encryption at rest and in transit for secure data transfer. The appliance is ideal for hybrid cloud use cases, including backup and recovery, long-term archiving, and cloud tiering. It helps organizations modernize their storage strategies without losing the ability to manage data locally, striking the right balance between on-prem control and cloud agility. Whether you're operating in remote branch offices, data centers with limited virtualization, or just want a hassle-free gateway setup, the AWS Storage Gateway hardware appliance offers a reliable, secure, and streamlined path to hybrid cloud storage. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.